So welcome everyone on behalf of the Global Sourcing Association, or the GSA. You've joined today one of the, I think the second or the third event we're running in the SourcingTech Series on behalf of the GSA. Sort of one-liner about the SourcingTech Series. The GSA is an organization that enables sourcing, and technology is becoming more and more critical to enable sort of enterprise agility within the business organizations and within the enterprise. And we've been focusing on some key technologies like AI, blockchain, 5G, IoT as key enabling technologies that are on the roadmap for every CIO, every CPO, and every sort of digitally focused organization out there that wants to adopt a digital technology and move forward. Today we're focusing on 5G, or for those, it also is called fifth generation, which I'm not 100% sure, but I'm sure the participants will shed some amazing light on that as to why it's called 5G. What we're going to talk about is introduction to 5G as a technology and what BT are doing with it. When we say BT, we're talking about one of the UK network operators that was acquired by BT a couple of years ago and still retains the EE brand. We're going to talk about 5G itself as a solution, as an enabler, what sort of benefits and opportunities it provides. We're also then going to look at spectrum assets, which are farmed out by Ofcom on a licensed basis within the UK, the regulatory and the spectrum aspects of 5G. Why are they so critical? And at the end, we're going to look at 5G monetization. How do you actually make money from 5G? What's the ecosystem you need? What's the roadmap to get there? By the way, my name is Ravi Veersubrananian. I have the benefit of being mostly silent today and just facilitating the proceedings. I'm a GSA Exec Council member, along with Kerry Hallard and Mark Devonshire. Next slide, please, Abby. I won't go into too much detail, but we've had, we've been quite successful in getting some industry-leading speakers to join today. So this is the running order. We've got Andy Sutton, who's a principal network architect at BT, followed by Phil Sheppard, who's had a long career history with one of the other mobile operators in the UK, but these days is a director and principal consultant for one of the technology consultancies within the mobile telecoms market called Clear Technology Consulting Limited. We've got Dr. Abhaya Sumanasena, who's the practice lead for spectrum and regulation at another industry consultancy called Rail Wireless. And finally, we've got Alastair Masson, who's the global client partner for Vodafone worldwide with NTT Data, one of the UK's leading SIs, which is a Japanese heritage SI organization. Next slide, please. A bit of housekeeping. This is the running order for today. So we've got an hour's webinar presentation with Q&A, and then we got an informal catch-up 30 minutes out for people who have availability and have continued interest in the topic. It'll be a bit more free-flowing. We're going to request each of the speakers today to take ideally 10, no more than 11 minutes to just run through their slides to allow 10 to 15 minutes for Q&A at the end. And I think we will, as part of the GSA, will make the slide decks and the recording of the session available after the webinar via our website. And Abby, am I correct that all the registered participants will get an email with a link to the slides?
Yeah, that's right.
Thank you. Just a bit of housekeeping. Please turn off your cameras if you're not one of the presenters or participants. If you're not one of the presenters today, please. Please stay muted during the presentations. And most importantly, please use the chat function to raise any questions, express any opinions. I will note take and bring up the relevant themes and questions towards the end, and we'll invite the most informed participant or the most informed presenter to just give his feedback or his insight on that particular question. And now I have the pleasure of handing over to Andy Sutton from BT.
Okay, thanks, Ravi. I'll just show my slides. Okay, can you just confirm, Ravi, you can see my presentation? Fantastic, that's great. Well, thank you very much to the GSA for inviting me along today. So I work in BT's network architecture and technology strategy team, where I'm responsible for 5G network architecture, focused primarily on radio access networks and kind of mobile access network connectivity, but I also work on a few kind of wider end-to-end topics as well. So what I'd like to cover is really just a quick introduction to 5G while I'm the first speaker, And then we'll see what we're doing within BT with 5G. And as Ravi says, this is commonly known as the EE network, our mobile network. So let's jump straight into the main deck. So it's very difficult to see a presentation about 5G without coming across this triangle. But it's actually a really useful place to start because it spells out the ambition behind 5G. You know, 5G is a lot more than just faster data to smartphones. It's a fifth generation of mobile communications, following on from the first digital technology, which is 2G GSM. Then we had 3G, UMTS, and 4G LTE. So 5G is continuing that journey, but actually the scale of ambition is very, very different. It's much broader. It's hoping to address a much wider range of use cases, from enhanced mobile broadband that we see at the top there, to ultra reliable and low latency communications, along with massive machine type communications. So real scaling up of the Internet of Things. Some of the examples we can see on the slide there include smart homes and smart buildings, as well as smart cities. We also see examples such as kind of working and playing in the cloud. So again, having that confidence that you're always connected to access content that you store in the cloud, along with features like augmented reality, extended reality, and we'll talk a little bit more about that later, and also industrial automation. So, really moving into new vertical industries where wireless technology can add some advantage, along with a whole range of mission critical applications as well, building on the kind of capabilities we've added to 4G. So there's another view here of that kind of evolving capability set. And interestingly, when we think about machine to machine, we often think about low data rate sensors and actuators making up the Internet of Things. But the reality is it could be very high data rate services, such as high capacity, high quality video that's actually going back into a computer system that's using facial recognition to grant you access in and out of the workplace, for example, or access through an airport. So there's a whole range of applications we'll see. And I've added the URLs to the various diagrams and information sources to the pack, which you'll get later. Now, the technology is targeting peak data rate, the downlink is from the network to the user, of 20 gigabits per second and 10 gig in the uplink. So these are targets. It will take some time for the technology to mature and reach those. For example, 4G LTE was standardized in 2008. It took about 10 years for operators to start to offer gigabit class services, which were specified back in that starting data. So we've also got some typical user experience targets now of 100 megabits down and 50 meg up. Now, you may well say, well, I can get that on 4G today. And absolutely you can. But the problem is you can't get that at rush hour at Euston Station, for example, in London, because of the sheer number of users trying to consume capacity from the cell. So 5G is looking to maintain that consistent user experience irrespective of load. And we also talk about lower latency as well. There's a lot of misunderstanding about latency in 5G. Typically, for a normal kind of mobile broadband session, then targets of 10 to 15 milliseconds are where we're practically aiming. That will really optimize the kind of internet browsing experience. And for applications that require lower latency, for maybe, let's say, automated manufacturing, for example, then we may be down at 1 to 2 milliseconds, but that'll be in a very bespoke configuration built for that factory. And then the minimum requirements for IoT connectivity or massive machine type connectivity is 1 million devices per square kilometre. So again, you get a feel for the scale of ambition. So what does it look like today? Well, really from a network perspective, there are three primary domains: the user equipment, the radio network, and the core network. And these are connected by the transmission network. So today, a legacy base station connects into, a legacy user equipment connects into an eNode B, so effectively a 4G base station. That 4G base station connects into the core network, a kind of universal gateway or serving gateway effectively, and some kind of mobility management pool that does the control plane. So when you pop the new 5G base station in there, the G-Node B as it's known, it's not interested. Legacy base stations will manage the legacy UEs. However, if we want to introduce a 5G mobile phone, 5G UE, and we want to make a voice call, actually it'll still use today the legacy LTE network. So it uses the voice over LTE service we've just delivered. So where does our G node B, our 4G base station, really come into play? Well, we see that here now. We see the 4G base station itself is actually connected to the 5G base station to support a data session. And that data session means that we can actually combine 4G and 5G carriers together to offer a higher data rate. So we're very focused on that enhanced mobile broadband use case today. Some of you may recall towards the end of the 3G period, it was really quite poor during rush hour to get a data session. The experience wasn't great. Facebook wouldn't load very quickly, etc. So as an industry, we've moved to mitigate those issues by bringing 5G in early to deliver this boost to enhance the mobile broadband experience. And then we continue to develop the URLLC and MMTC features through different releases of standards. So what are we doing in BT? Well, effectively, here's an example of our network architecture. The key thing from a sourcing perspective, of course, is that 2G, 3G, 4G, 5G all continue to coexist. We need higher capacity cell site routers to hook all this equipment together. We're deploying more optical fiber equipment, including very high capacity systems and multiple 10 gigabit per second links. And where needed, we're deploying millimeter wave point-to-point radio. I'm showing an E-band radio as an example here to actually extend the reach of that fiber point of presence. All of that then feeds into the core network. Now, the core network is interesting because as we evolve from the core network we've just seen, which is the evolved 4G network, we move into the 5G core network. And here's an example 5G core network. I'm not going to major on all the functions in the interest of time today. There is a paper at the bottom there that explains them if anyone's interested. However, the key thing to say is we can separate this out into a control plane and a user plane. The control plane is all the stuff in the dotted little box there, and the user plane is that UPF, user plane function at the bottom. Now, the interesting thing from a sourcing perspective, again, is all of this equipment can be virtualized. All these functions can be virtualized. So rather than going out and buying a monolithic platform that serves one function, you effectively buy commoditized compute, you buy a cloud operating system, and you buy network functions that you load onto that cloud instance. So again, a very different way of thinking about not only building networks, but actually procuring the elements that make up the network. And we'll start to see next generation core services probably from about 2022 in many networks around the world. So we launched our network, the EE network, on the 30th of May 2019, a launch event on the River Thames there. And since then, we've been exploring the art of the possible, not just higher data rates for internet browsing, but also what can we do with augmented reality and extended reality, both for leisure, but also for business as well. There's a paper available if you want to know a little bit more about how we've built the network. This was published at the end of 2019. And again, the URL is included. So to summarize this short presentation, 5G supports enhanced mobile broadband, ultra reliable and low latency communications, along with massive machine type communication, the evolution of the IoT. It opens up a whole bunch of new and exciting opportunities for industry verticals, including a concept of private and non-public networks. And you're going to hear more about that from my colleagues. So it's a lot more than just faster internet to smartphones. It'll be deployed across a wide range of frequency bands to address a variety of use cases and deployment scenarios, from wide area IoT, providing coverage in basements, right the way through to very high capacity and low latency services in smart manufacturing. Next generation core network will enable these new services and include features such as network slicing, so the availability to deliver bespoke services over common infrastructure. And from a BT perspective, we're working very hard with academia, with corporates, with industry partners and international standards bodies to really maximise the benefits of 5G for the UK. So it is an exciting new technology. There's a lot of supporting technologies, some of which I've touched on as well, that go around 5G to make it into a complete end-to-end system. So I'm going to hand you over to Phil now, who'll continue the 5G story, and I look forward to your questions later. Thank you.
Thanks very much, Andy, for that. Excellent segue. I'll just share my slides as well. 1 second. Hopefully you can see that there.
We can indeed, Phil.
Fantastic. Thank you very much, Andy. Quick intro. I am currently a director and principal consultant at my consultancy company, Clear Technology Consulting Limited. Previous to that, I was director
Phil,
of
did you want to come onto the camera?
Can you not see the camera?
No.
Okay, let me just.
Up to you. But it was just...
I should be on camera, but let me just try again.
Yeah. Yes.
Can you see me now?
Yes. Thank
Okay,
you.
something went wrong there, obviously.
Right.
Okay, thanks for that. Thanks for the. Otherwise, it'd just be a blank piece of sound. So just a quick intro. I was previously director of strategy and architecture at 3, and that involved being responsible with myself and my team for the end-to-end architecture and strategy, particularly of 4G and 5G. And I was also responsible for sourcing the vendors and products as well. So that's hence somewhat interested in supporting a GSA event, because that's a key part of a role when you're doing architecture and strategy. So I'm going to just talk about opportunities for 5G, and by way of introduction, GSMA, which is the Global Mobile Operators Association, have forecast the contribution that 5G will make to the global economy by 2034. So this isn't the 5G network itself. This is a contribution towards all the different industries and businesses in the economy, and it's obviously a large number. And so why is that $2.2 trillion there, and why do they think that's the case? And I'm going to sort of just mention a few use cases today, which hopefully we'll look at that and see where that could be coming in. Just to show you where we are with 5G at the moment, we're very early days in terms of the number of 5G. See here again, GSM Association actuals and then forecast beyond 2019 as to where they think 5G connection will be globally. The numbers obviously takes quite a long time globally for technology changes, because people have to swap out their devices, handsets, etc., in order to get 5G. UK probably will be in advance of this, given where we are with the fairly early launch of 5G globally, and also I think devices like the iPhone just come out that supports 5G will now accelerate device support. So I suspect I would predict we would be somewhat ahead of this curve, the global curve. Andy's already mentioned architecture, so I won't go into any more real detail, but obviously just to mention that a 5G network isn't just one piece. It actually needs changes throughout. Virtualizing the core network is a key part for 5G going forwards. The backhaul network, the piece of transmission and fiber, etc., needs to be upgraded and distributed. And then the sites of the mobile sites and masts need new radio equipment and, crucially, spectrum. And then quick word on spectrum. We have a real expert on spectrum next to Abhaya, so I won't steal his pitch, because he's a real expert on this. But just to mention a couple of things here, 5G, the advent of 5G in UK, and this is similar elsewhere, is the key thing is there is additional spectrum being made available for it. And the spectrum that's being used in the UK is this 3.4 to 3.8 gigahertz range. And then in the future, there will be some what are so-called millimeter wave bands, which is the 26 and beyond gigahertz frequencies. So the spectrum that's there at the moment is in the similar range to the current mobile and Wi-Fi range. It is as safe as any other mobile and Wi-Fi system. You just have to manage power levels in the same way that you do with any other mobile technology. It's well below the rather dangerous levels of gamma rays, etc., and X-rays. The key thing to the performance of 5G is, number one, spectrum, and the addition of the 5G spectrum, just the bit that's being used at the moment, not the millimeter wave, is an additional 73% of spectrum in the so-called sub-6 gigahertz range, which is the main range for mobile. So that's a significant increase in capacity and potential. The other big thing on 5G is that the carrier bandwidth, the amount of spectrum that a device can address, is a lot wider. So the carrier size for 5G at these mid-band frequencies is 100 megahertz, whereas 4G was limited 20 megahertz. So Andy mentioned carrier aggregation. You can aggregate up to 5 if your device supports it in order to get a similar bandwidth, but you cannot do that in one carrier. You have to aggregate. 5G, you can do one single carrier that does that. Spectrum's a complicated thing in the UK now. Lots of different holdings, lots of different frequencies. Again, I'll leave it to Abhaya to maybe say more. But the spectrum holding you have determines very much what sort of coverage you get, what sort of capacity, what sort of speeds, and where that is. And that's a key piece of, if you like, sourcing is acquiring spectrum. The next thing that really is a big shift in 5G technology, and actually some of this can be used on 4G as well, but it's really come of age with 5G, is the antenna technology. So antennas are the means of transmitting and receiving radio signals, and traditionally it's been what they call a passive antenna, but it's moving towards a called active antenna, which is this thing called the 64T64 on the right, which is called a massive MIMO device. There are very different configurations and sizes of that. And the key thing to know about massive MIMO antennas, they're not actually massive in terms of size. They're actually a little bit smaller than a traditional antenna, but they have a lot of elements in there. And the large number of elements allows you to do a thing called beamforming, which basically targets the send and receive of the radio signal. And that extends the coverage range, and it also extends the capacity. So you get a big boost from deploying the right technology as well as the additional spectrum. Just a quick overview of what a radio site looks like. This is a real one from the UK, courtesy of Peter Clark, who does a lot of pictures on Twitter on this sort of thing. So a radio site consists of typically at the top radio units, remote radio units, which send and receive, in this case, a 4G signal. The antennas, these big tall things to transmit and receive the signals. The size of that rather depends upon the spectrum bands that you're using. A lot of mast infrastructure, i.e. steelworks and support, because this stuff is quite heavy and it gets affected by wind, so it needs to be very secure and upgraded. And then if you're adding 5G, there's two options you've got. One is to put this unit, which is the massive MIMO unit. So you can see it's not particularly large. It has got a lot of elements in it. Or you could do an additional radio unit and use the traditional antenna. So both options are possible. The massive MIMO is the better option, but where you can't fit that on for any reason, then you use the radio unit. I had to put this on. Sorry, Andy, I couldn't resist keeping it in, but Andy's already put this on. The triangle, but the triangle is quite good because it illustrates there's a whole range of applications that are enabled by the various different aspects of 5G. And I quite like this little graphic from Ofcom, which basically summarizes where the opportunities come from 5G. And it is around more, and I say faster data. It is more devices, which is the IoT side of things, and it is the instant response, which is the ultra low latency or low latency solution. So that's quite a nice little graphic. And I just wanted to do a little bit of a reality check on some of the key attributes of 5G. The first two I'd like to just focus on is speed and latency. The other attributes I've listed there, and I'll say a little bit about the architecture, but the other two are fairly obvious. So this is the speed view. So the 5G vision, as Andy also mentioned, is 20 gigabits per second. Now that is a peak theoretical speed, and in very ideal conditions with only one device connected. So it's useful as a technical aim, but it's not very useful to describe what the actual experience will be. The current 4G is peaking around about 150 and averaging around about 20, maybe a little bit lower, but I rounded it to a bit higher than 20 megs. I rounded it to make it nice maths. And then the current 5G, if you look at a full bandwidth 100 meg deployment, you will get about 1.5 gigabits per second peak. That's the very ideal condition peak speed, averaging around about 200. Andy mentioned 100, so between the 100 and 200 mark in real load conditions is what you can expect from 5G. And latency point of view, again, Andy mentioned this. Latency is, I entirely agree with what he said in terms of what the actual aim and where we're going. So the headline is the 1 millisecond latency. That is misinterpreted sometimes because that's a one-way latency. Actually, it's 2 millisecond when you do a round-trip test with things like speed test. But the reality of a wider network deployment is it's targeting the 8 millisecond number, and that in reality is coming out to around 10 milliseconds round trip time in a real network. Extremely good compared to 4G 40 milliseconds, and it makes a big difference to human interaction. It's not quite the ultra low latency, and as Andy says, that will be more of a specialist deployment, things like factories, etc., mission critical networks. So what does the high speed mean and the low latency mean? So from a real user's point of view, the very high bandwidth, it means many things on many applications, but for video, it will give you a much better experience. You won't get buffering in terms of starting the video, and you won't get the sort of stuttering as you go through because the average speeds are also there. Latency comes into us in many applications, but particularly in gaming, a high lag or high latency or high ping, as they usually refer to, will make it difficult to win games because your response time is slowed down by it, and that's the key thing in latency from a gaming point of view. But however, it's important to really sanity check. So there's a lot of numbers on here, so it's not really terribly important, what the numbers are. But if you look at new applications that have been proposed, this is a panoramic video, so where you can stream the entire 360 video stream, and it certainly 5G certainly enables a much better quality experience. But there are limits. If you want to do the super high definition 12K and a full sphere, it just isn't going to be possible with the current 5G deployments to get a reliable service. But some really great stuff you can do on, say, 4K or 8K streaming. Cloud gaming is another application that's been pushed quite a lot as a new application. Cloud gaming is the architecture of cloud gaming is that the video stream is created in a set of servers in a cloud, if you like, or in an internet data center, and then streamed over the network connection. So you don't have to have all the graphics processing in the device that you've got. You can have a cheaper device that just displays the video, and indeed you can get I believe you can get quite reliable 2K video streaming for cloud gaming on a 5G network, but it starts becoming a bit less reliable in the 4K range because you're around about the average speed for 5G, and that means sometimes you won't get it. And
we might be running behind the clock a bit now.
It's okay. I think I've got 2-3 minutes left, so I'll be fine. Okay. Yeah, it'll be okay. Now, thanks for the reminder. Yeah. So I'll whiz on quickly with that reminder. So on the architecture side, is the next big thing. Architecture of a mobile network. I haven't any of the detail that Andy did here, but a current mobile network is designed for a whole range of applications, utilities, automotive, etc., manufacturing, and you usually use the same network architecture. Network slicing is a new thing being introduced to 5G when we have 5G standalone networks particularly, and that will enable a different quality of service for different applications. So it really specializes in terms of capability. And that plus the 5G performance will give rise to a whole range of new applications for all types of things, from industrial IoT through critical communications through mobile broadband. So I think it's expanding the range of things that you can use a mobile network for. And again, Ofcom have recognized this and actually have released some additional spectrum in order to allow things like private networks to be operated potentially by people that aren't just mobile network operators. So there's a whole range of opportunities, a whole range of different applications that I think will start appearing in the next few years. So my summary is that 5G does create a lot of new opportunities. However, do be careful just to reality check it. That the hype can sometimes be believed as to the speeds and performance that actually has been deployed. I don't want to be negative about it because there's some real positives. It is really good, but just be a little bit of reality check. So be positive, but be realistic. With that, I will hand over to Abhaya, who will talk about spectrum.
Thank you, Phil.
Thank you, Phil. Can you see my slides? Please let me know.
Yes, I can hear them, see them, Abhaya. Yeah.
Great, thank you. So my name is Abhaya Sumanasena. I work for an independent wireless expert advisory firm called Real Wireless. So in Real Wireless, we work closely with both the operators or in wireless industry and wireless users. That consists of operators, regulators, and solving a wide range of problems related to technology and spectrum. So I head the spectrum and regulatory practice, doing various things about spectrum and regulatory sides. I had the pleasure of working with both operators and regulator environment. Therefore, I was able to understand the narratives from both sides. So just to introduce a spectrum, I think Phil touched on this. Spectrum is invaluable asset for all radio users. Now, don't forget, our focus here is mobile spectrum, but there are many other spectrum users need spectrum. It's a scarce resource because the demand mostly exceeds the supply. Good thing about spectrum is it never wears out. It can be repurposed. In fact, the spectrum that we use for 2G and 3G, most of the operators now deploy 3G and 4G or even 5G using the same spectrum. So therefore, you can use it and reuse it. Obviously, spectrum has different properties. You can see in this diagram, the electromagnetic spectrum is actually quite wide, but there are some portion of spectrum we call radio spectrum provides better conditions for radio wave propagation. That's why that part of the spectrum is very valuable, and all the radio users try to get hold of this spectrum. And you can see Phil also mentioned lots of services that we use for radio services are concentrated in some parts. What happens when lots of users use the same part of spectrum is they introduce interference to each other. And that is the role of the regulator, national regulator, is to manage this interference and also to optimize the use of this spectrum. I would like to approach this in a supply-demand point of view. So we know it's known that data consumption in mobile networks increases. So that is the demand side. Now, in order to serve this demand, operators have different options to increase the capacity in their networks. So firstly, increase or upgrade the technology. We talk about 4G, 5G. So what does technology do? It increases the spectrum efficiency. In other words, more advanced technologies has a higher spectrum efficiency. That means from the same amount of spectrum, the amount of data it can carry increases. That's why we deploy 4G and 5G latest technologies and use the old technology, spectrum use for old technology to deploy latest technologies. However, there are limitations. Obviously, Phil mentioned this and mentioned this, you are dependent on the UE capability. It doesn't matter you have the 5G base station, but your mobile phone doesn't support 5G, you cannot have 5G. So terminal penetration, therefore, has a limit. It progresses slowly. So when each individual user have their 5G capable handsets, that's when everyone can benefit have the benefits from 5G, and also operators can have the benefits from 5G. So the other option operators have is to increase the network infrastructure. We call it densification. So deploy many more sites. However, as you know, the deploying sites is very expensive. We mostly in the range of £100,000 compared to deploying a new macro cell site. So they have very expensive. So there are limitations also where you can deploy sites. And the other option you have is spectrum. So this is why now spectrum, if you have additional spectrum, upgrading your sites with additional spectrum costs much less compared to deploying a new site. That's why operators really want to get hold of the spectrum. So benefits to operators from additional spectrum includes it gives higher capacity. I think Phil mentioned loads of users can experience higher data rates, so service quality, faster data rates, and also increase the coverage. For example, low or sub 1 gigahertz spectrum, 800, 900, and 700 megahertz spectrum, which is on the offer in the auction next year. They are very good at penetrating deep into the buildings and propagating much further away. So that means the number of sites you will need to cover a certain area is low. It also provides some kind of strategic values for operators. For example, this is a share price, Vodafone share price. You can see in 2000, when 3G spectrum was offered, share price increased significantly. It's not only due to the acquisition of the spectrum, and also later years we found that the spectrum doesn't really change too much. However, there are some other benefits, like if you have more spectrum, it's easy and you can deploy services much faster. Now, what are the key bands considered for spectrum? Phil touched on this. So firstly, 700 megahertz, a very important band because these low spectrum bands, as I said, they help you get coverage, mobile coverage inside the building. So none of these high frequency bands, it's very difficult to, they don't penetrate through the buildings. Therefore, you don't really get coverage. Therefore, every operator try to get hold of sub 1 gigahertz spectrum to increase their coverage layer. However, that's not the only side, right? You have to serve the demand. You need to have capacity in the network. So that's how these higher spectrum bands help. So the key spectrum bands widely considered for 5G deployments is 700 megahertz band and 3.4 to 3.8 gigahertz band, 400 megahertz of spectrum, and also 26 gigahertz band we call millimeter wave band, about over 3 gigahertz of spectrum available. Now, these three bands are also known as pioneer 5G bands and harmonized across Europe. In addition to the spectrum, so there are other drivers or enablers coming from spectrum because of 5G. For example, 3GPP has standardized about 48 different spectrum bands. So here I mentioned 3 different bands, but there are 48 different bands standardized for 5G. What it means is equipment manufacturers put these plans into their roadmaps, which helps developing the ecosystem. Not only that, 5G also have some new features. For example, Wi-Fi spectrum, the spectrum that we use for unlicensed spectrum that we use for Wi-Fi, in the future release or 3GPP release 16 5G version, that enables operators to deploy, use this spectrum, the spectrum used for Wi-Fi, and provide services using that spectrum. Obviously, that there are certain conditions related to quality of service. Those conditions have to be comply with those conditions, but it gives additional spectrum, access to additional spectrum. Phil mentioned this as well. Access to high frequency bands like millimeter waves is available. It's an opportunity from 5G. Now, it's important to mention that these spectrum bands actually, the way regulators think about spectrum band is technology neutral approach. That means the spectrum is actually not specific to a specific technology, but most widely used is what we are considering here. So other options, other features like dynamic spectrum sharing, where operators have the opportunity to share the same spectrum for different technologies like 4G and 5G. You can deploy using, we can see now 2.6, there are products emerging for 4G and 5G. So operators can share the spectrum for different technologies, and wide use of carrier aggregation opportunities available from 5G. So these are the key, I think, enablers that promises from 5G, and also key spectrum bands considered for 5G deployments. In addition to that, there are new trends emerging on the spectrum side. One of the interesting frameworks that Ofcom has also introduced is local access spectrum. What it means is, if you look at this diagram, this shows the demand across the UK, mobile data demand across the UK. You can see it's really concentrated. It's really within the areas where people usually live, right? Most of the areas are the areas that there's no demand because probably nobody lives there. However, this is why the local spectrum, access spectrum is important. If for some reason, because of new opportunities for new use cases, if somebody wants, service provider wants to deploy a service in these areas, there's an opportunity now in the UK for apply for a license that already licensed to MNOs. The bands are here, that already licensed to MNOs currently use. If the operators currently don't use or don't have plans to use within the next 3 years, anybody can apply for these licenses and use within a local area. And there are some conditions. You have to start transmitting once you acquire spectrum, and operator has to agree this, but there's a process, there's an opportunity for new users to get access to the spectrum. Not only in the UK, there are Germany has set up aside 100 megahertz of 3.7 to 3.8 gigahertz band for local use. Finland has some opportunity, some local access spectrum within 2.3 gigahertz band and 26 gigahertz band. And also the Sweden and Hong Kong is thinking along the same lines. The other interesting trend emerging is shared spectrum, that UK has, Ofcom has put a framework forward to share some of the spectrum bands. So these are not this is 1800 spectrum is about 3 megahertz bandwidth, which is not the usual 1800 that operators use. We call it depth guard band, small portion of spectrum that is not currently being used widely, and 2.3 gigahertz band, also 3.8, 4.2 gigahertz band. There's some opportunity for new spectrum bands, and users can apply. They can share the spectrum and get the spectrum first come first serve basis of assign these spectrum bands amount of bandwidth, and you can pay a little license fee and have access to this spectrum. So these are new opportunities available, not necessarily because of 5G, but some emerging trends coming from spectrum side. So in summary, I would like to say spectrum is an invaluable asset. That's why mobile operators really want to get hold of these spectrum bands, because without spectrum, you cannot have a radio communication system. Additional spectrum provides significant benefits, and each spectrum band has a role in the network. Some helps capacity, some bands help to achieve coverage. So therefore, it's important to have the right balance between this among these different spectrum bands. So additional spectrum will really help operators to get better use of their sites, getting more capacity from the existing sites if you can deploy additional carriers. It's a cheaper way or more economical way of getting capacity. And new 5G spectrum features and also emerging trends provide new opportunities for operators and service providers to access to new spectrum bands. I will stop there. And next, I think it's also very important to understand how can we, so what does it mean, this technology, what can it deliver, and how can we make money, monetize these? So Alastair will talk more about this.
Thank you, Abhaya.
Thanks, Abhaya.
And lastly but
Morning,
not least, Al. Yeah, keep going. Sorry.
Thank you. I'm going to assume you can see my slide, Ravi, unless you start waving.
Yes.
Vigorously. I'm Alastair Masson. I'm the global lead for all of NTT Data's business with the Vodafone Group. And just to be clear, what I'm going to talk about today is representing the NTT Group perspective. It's not the Vodafone perspective. I've been fortunate to work in the telco market for really a very long time, both on the operator side and on the services side. And I've seen a lot of big shifts in the industry, and 5G is certainly as big, if not, the biggest that, we've seen so far. So today I'm going to cover three different aspects. One is, the promise of 5G. We'll also touch on quite a bit of the hype of 5G. There's a lot of that around. Secondly is some of the emerging use cases. And then third, the implications for procurement and the way in which 5G and all of the associated technologies are sourced. First of all, a little bit on who NTT Data is. We're around about a $19 billion turnover services business. We deliver consulting and also systems integration to a multitude of industries across over 50 different countries. We're also notably part of the NTT group of companies, which is a $120 billion turnover group that boasts in its family one of the most progressive mobile operators on the planet, and that is NTT Docomo. And I'm going to be talking a bit about NTT Docomo throughout this presentation. We also do a lot of R&D around communications and technology. And you may be grateful or resentful for the fact that the NTT group actually brought the emoji set to life in the late 90s. But I mentioned communications and technology, and certainly in terms of 5G, we see that this distinction between the two is becoming increasingly unhelpful or just irrelevant. And 5G is a great proof point to demonstrate it. Both Andy and Phil spoke about things like cloud. They spoke about open source. They spoke about virtualization. And these are concepts that have come from the technology, the IT space, and are very much now front and central around what 5G is in a 5G enabled world. I'm going to break now just for a short video, and then I'll be back. But this is the NTT Docomo promotional video that sets the vision for 5G. Okay, so 5G, it's anywhere, it's now time, it's immersive, it's across all realms of life. And so much about the vision for 5G is how it enables some of the greatest social and human grand challenges, things such as in education, in medicine, in agriculture, but also on the lighter side of life, areas such as gaming, entertainment and sport. And the key thing here is about how 5G enables a far broader set of engagement, and with the challenges that we face as a species at the moment, brought about by COVID, who would argue that 5G has ever been as important as it is now? But this is still a little way off. And, you know, it's important to remember that 5G itself is an enabler, and Andy and Phil covered the triangle. This is a higher level view of that triangle. So what I'm going to do now is move on to where we're actually seeing the services coming from. Now, there's a whole raft of work that's going on across the world at the moment. I'm going to share some of the work that we as a group have been doing over in Japan. And these are the things that are actually creating value across the various different realms of life, some of which we saw in the short video a moment ago. In manufacturing, we're seeing massive demand for 5G, especially around the characteristics of massive connectivity and ultra low latency. It's being used to manage uptime to levels that would have not been seen before. And increasingly, something that both Andy and Phil mentioned, we're seeing numbers of manufacturers deploying private 5G infrastructure to support increased levels of monitoring to keep things rolling. Let me give an example. One of the earliest collaborations that NTT Docomo had in Japan was with Komatsu. Now, Komatsu are one of the manufacturers of heavy earth moving equipment, and the 5G solution was used to provide a remote control service for heavy earth movers where the work was happening in remote areas. Now, that was able to increase the efficiency of manpower because people weren't having to travel backwards and forwards from site, and also, really importantly, it was improving safety for the workers as well. And if we look at entertainment and sport, especially with the impact of COVID, we're all deprived of a lot of what we previously took for granted around those two things. 5G is helping to enable some new engagement technologies in those spaces. One of the things that you can do is Google the work that NTT have been doing around the Open, which is the largest, probably oldest and most well-known golf tournament in the world, and also more recently the IndyCar 500 event that ran in August. So we've really tried to focus in around how we can bring together connectivity and technology to enable engagement in ways that has never been possible before. One of the other things that we saw on the triangle from both Andy and Phil was smart cities, and Las Vegas and Tokyo are great examples of that. About 18 months ago, we went live with Las Vegas. This was all about massive connectivity to enhance the safety of citizens there, and also to reduce the friction of people moving around that place. And in terms of Tokyo, certainly the friction of movement around the city where IoT, 5G enabled solutions were deployed. Now, you know, this is all great, but actually to realize all of these new things means renovating some old ways of working and also introducing some new ways of working. So what I'm going to do is cover 4 aspects now. So first is the way in which the value is generated. Now, traditionally, value has been created through what I refer to as inside out. So product development teams within operator organizations will figure out, right, here are the services that we think that people need. In a 5G world, it's more about outside in, and the outside in this context is the ecosystem. New services in a 5G world are going to be composed of multiple moving parts, each of which come from the ecosystem and derive value from it. So, you know, the new wave of things is not just about 5G, it's about all of the inherent components that are connectivity and also technology that make up the solution. But really critically, it's also a business model shift that we're seeing here. We think about the way in which an ecosystem operates, there are multiple points of value in it. And the business models that we're seeing developing are becoming more transactional. We're seeing less in the way of just single products. So that economic ecosystem has to work as well. Revert to manual. how we explore and discover value in that ecosystem. And that requires partnership. It requires a lot of collaboration between a lot of partners arriving, partners leaving. It's going to be one of constant change. Sometimes, inevitably, you're going to take a wrong turn. So businesses must be equipped and willing to fail and to learn from those failures. I remember back in the late 90s when I actually worked for Vodafone, we launched the prepaid offer. That first time through, it failed. Short while later, Vodafone then launched their phone in a box offer and never looked back. So the lesson here is, always try something more than once. An old client of mine once said after we had a bit of a failure, just remember, Alastair, the first mouse never gets the cheese. So if you think of the mouse and the trap scenario and the bit of cheese in there, I'll let you just think on that metaphor. Always try something more than once. So how do you find a way to experiment across and within that ecosystem? Again, another example from the work that NTT Tacoma has done in Japan. We established a new division, so a new division within the business for cross-industry creation and collaboration. And it's already identified over 200 co-created use cases, with some of the biggest numbers coming from manufacturing, media, real estate, and local government. There are 6 elements to that. I can follow up offline if anybody's interested in those. I'm conscious of time at the moment. So I'm now going to move to the third area. And that is that with the coming together of communications and technology, these co-created 5G-enabled smart products are going to require a new style of procurement. So, we recognize that there are going to be fewer big bang, fewer monolithic events, and more in the way of very progressive procurement styles. It's going to be less about best price, more about value and transaction-based deal economics that can shift as the shape of the offering changes. Everybody crucially has got to have skin in the game. We're also going to see and require a change to how service and the quality of that service is managed across this multiplicity of ecosystem components. Fourth and final, this is about how, as businesses, we can create full end-to-end, low-friction connectivity across the whole supply chain. So connecting procurement to the sell side of our businesses as well. One of the biggest areas that's going to drive income from 5G is going to be in the B2B space. So therefore, the part of the business that procures has also got to be connected with the part of the business that sells. And because there are going to be so many constituent elements, it's really, really important that that works in a slick, well-oiled way. So that increase in complexity, increase of speed of doing business is also going to require change. So, in summary, this really has been a bit of a low latency presentation. The reality of 5G, it lags behind the vision. Look, that's inevitable. It's a good thing. Vision pulls through reality, and generally speaking, reality arrives sooner than we expect it will. The next thing is nobody's got all the answers. There are gaps. Make mistakes. Customer value is going to come from this complex and ever-moving ecosystem of connected technology and connectivity capabilities. So learn how to work with those. It won't be right first time. So build experimentation and failure into how you're actually innovating around the offerings. And we won't see success in smart solutions using traditional procurement approaches. So be progressive. Pick those players and those partners who pass the Pittsburgh Airport test. Pittsburgh Airport is apparently the most boring airport on the planet. It's those organizations you can work with elbow to elbow as equals and connect procurement and supply chain end to end from sell through to buy. Speed is very much of the essence. Thank you for listening. I've galloped through that. You can find out more on our website, or equally do please feel free to connect with me on LinkedIn. We're going to questions now. So Ravi, I'm going to hand back to you. Thank you.
Okay, what I'm going to is take the screen. I do have the questions. I've been scraping that from the presentation. Can people see my screen? Apologies. Yeah, just restart. Can people see my screen?
Yeah.
Okay, so these are the questions that have come up. I'll start with the ones that
Don't know
I
if
think
anybody else. I'm getting a lot of echo, Ravi. I don't know if somebody else could go on mute. Maybe we could go on mute just to make sure.
So is that better?
Yeah, perfect.
Okay, I think there were some common ones raised here during Andy's session, and let me try and oops, my mouse is running a bit slow now. This one, yeah. Did you want to start? Yeah, these. I mean, I don't know who's. It's probably Andy and Phil, a mixture of both of you, talking about. Do you want to talk about? Do you want to pick up the ones that were just shaded in yellow? What is the current roadmap? Device brackets UE support for new radio plus 5G times LTE carriers.
Yeah.
What are the EMF challenges and solutions IC and IRP for rolling out massive MIMO?
Okay, well, if I take the first one, do you want to take the second one, Phil? And we can bounce ideas around that way.
Yeah, that's perfect.
Okay, so the actual initial LTE, the initial 5G new radio devices are designed with support for carrier aggregation. Because of this ENDC mode of operation, this kind of non-standalone mode that I illustrated through the architecture steps there, today when you connect to a 5G network, you actually connect over the 4G control plane, so 4G signaling network, because that's a wide area coverage. And today we use 5G as a capacity boost, effectively a speed boost, to help to kind of maintain and enhance that mobile broadband experience. So from release 15, when we introduced 5G devices, those devices would support new radio and up to 5 20 megahertz LTE carriers. And that was from the specification from 3GPP. So those devices in the market today, we do see that usage on the network. Clearly, it depends how many carriers an operator has deployed to the base station as to whether 5 are actually available. So that would depend upon the particular strategy and the spectrum holding and the investment that particular operator makes. But certainly on the EE network, we have 5 carriers deployed in parallel with new radio. Depends a little bit on the amount of traffic, the data rate that wants to be consumed by the user. If it can be dealt with by NR, that's fine. If not, then we bring additional carriers into play as well, depending upon the demand and the buffer fill rate. So that's to do with the way we optimize the scheduling engine. But actually that mode of operation, that non-standalone mode of operation, where we share 4G and 5G radio, is actually very common today. That is how 5G operates on most networks.
Okay, shall I answer the next one, the EMF one?
Yes, please.
Yeah, apologies. I seem to have gone dark. Teams decided it's not going to give me any brightness, so I can't fix it. So, still hear me at least anyway. So yeah, so just to give a background so people understand the question here. ICNIRP is the regulation that specifies what's a safe level of radio power that you can transmit. So I'm looking at the next yellow one, by the way, just right here, yellow on it. Typically, you have to calculate the amount of radiation and the power and limit that so that you don't get any levels of exposure that might cause heating, typically, and therefore potentially some damage to people. With a massive MIMO antenna, it has the beamforming capability, and that means it can focus and concentrate power into a narrower area than a traditional antenna. So the way that's been dealt with so far is to take a very cautious approach and to reduce the amount of energy that the antenna can transmit to compensate for that. That means you can't extract the full value and benefit from that antenna if you use those very cautious and very safe approach. So what's being worked on and has been worked on is what is the actual statistical power that you will actually deliver, and also the antennas, can they manage and limit the power in any one direction so that then you will be able to more safely use the full range of it. So it's had quite a look at it. It's being worked on in terms of optimizing that, but always being taken the most cautious approach. And if you look at actual power levels being transmitted on 5G sites, they are a small fraction of the safe limit by a very tiny percentage. That's it, I think, Ravi.
Thank you, Phil. And thank you, Andy, as well. I think the next question, there were two common themes that I picked out that came up during Andy's. One came up during Andy's pitch, which was for BTE, who have announced the Nokia decision will Open RAN play a part in the access network anytime soon. And then the other one came up during Alastair's presentation. The UK government has launched a task force to address UK's limited diversity in the vendor ecosystem. Now Huawei are restricted and Nokia Ericsson are dominant. What alternatives do the panel see as viable? Andy, I think, do you want to talk first on the BTE position?
Yeah, if I take the first one and then hand over to Alastair. So yeah, it's a really good question. And Open RAN is being developed by the Open RAN Alliance, which grew out of what was the XRAN organisation. BT is a member, an active member of the Open RAN Alliance, so we're contributing to the developments of the specifications to allow Open RAN architecture. Now, for those not familiar, Open RAN is looking at the ability to functionally decompose the radio access network into a number of subcomponents for the radio unit, and then taking that digital section, the baseband unit, and decomposing that into two further sections as well. And you can place these in different parts of the network to achieve different levels of optimization. But actually the open aspect comes into play because the idea of the target is that you could actually buy each of those components from a different vendor and plug them together, and they would work perfectly well, which isn't the case today. Systems today are closed in that regard. So Open RAN is something we're extremely interested in. We think it's going to drive innovation. It's going to drive probably commercial benefits, but also we think it's going to open up the market to a lot of specialist vendors who may not want to play in the whole end-to-end space, but want to develop particular components within that decomposed radio network. So the initial rollout with Nokia that's been announced will be a traditional radio access network in the macro cell network, and that's where the technology is today. We think the first opportunity for Open RAN will be around in-building deployments. I think that's a good place for Open RAN to really start to prove itself, going to cut its teeth really, because there's slightly less stringent requirements around mobility and synchronization, etc. So we think that's where Open RAN can start to grow. And then beyond that, small cells in the external network, and then into macro cells in the fullness of time. So we're fully behind a complete Open RAN architecture across the entire network. It's just a journey that we're going to be on over the next kind of 5 to 10 years in reality. And Alastair.
Yeah, thanks, Andy. So, I mean, to the point of diversity in the vendor ecosystem following the news and decisions around Huawei, I think actually the challenge is bigger than just diversity in the ecosystem, because for so many operators, the bidding tactics and the levels for spectrum, which Abhaya spoke about earlier, were driven by the cost of investment in network infrastructure. Now, that particular block has been pulled out of the Jenga tower. So the problem is more fundamental than just diversity. The problem is now kind of business model, and do the economics still work? And the truth in all of this is that it is going to be more expensive, and that needs to be passed on somehow, or it needs to be met somehow. Now, I'm not clear on what the government standpoint is on that. So ultimately, if we assume there isn't going to be anything material happening from government, the buyer of the services will pay ultimately for what has been a more expensive rollout. But on the alternatives point, I think Andy's absolutely hit the nail on the head. The Open RAN side of things is the alternative, and just like in nature, business kind of finds its level, it evolves, and there are operators at the moment who are now trialing Open RAN in their networks, and we are working with businesses like Mavenir, with Altia Star, and in particular we're seeing a lot of the Open RAN technologies really maturing in a private 5G context where there are campus networks. So yeah, that's where I stand on that. It's a bigger problem than just the numbers. It's actually an economic issue that we have got ourselves into. But Open RAN is I believe a big part of the solution going forward.
Great, thanks, Alastair. Thank you, Andy. I think it clearly shows that this is a global. This is not. I mean, there's a security aspect to Huawei, but there is the global perspective on the supply chain and development of future technologies and services around this.
Yeah, sorry, Ravi. I mean, the security thing's an interesting point. So part of our group is NTT Security, and we've got a sort of global threat intelligence network, and one of the things that we know is that security is all about relative things, and there are I'm not backing Huawei, by the way. Here, I'm objective, but there are more security breaches that happen for reasons that are not Huawei, that through fat fingers and such like, than actually through the fundamental equipment.
Yeah, I think there's a political aspect to it, which is sort of beyond the scope of this particular discussion. I think I've highlighted a couple of questions in, I think that's called turquoise, but I could be colorblind. Abhaya, I think you probably best with maybe input from Phil to pick up these. I'll read them out. Has the government green-lighted 5G funding or left it to the industry? It appears it would be more helpful for all of us in Team GB if HMG funded 5G that we need now over HS2 that we don't need so much. I think let's leave the second point out for a different discussion. That's probably a bit political. And whether you prefer a train or a 5G antenna, don't know. Can you outline how UK government are enabling the Department of Digital Culture and Media and Sports and Ofcom? How do they interact? Who is the lead 5G minister and shadow?
Okay, so interesting questions. Thank you. And certainly, so government, UK government, just like other governments, actually, there was almost a race among the governments and the industry to get and deploy 5G fast. But I think so UK government has also done a lot of things to make 5G happen in the UK. Firstly, I think we probably heard about UK test and trial program where many regions, where I think specific locations, 6 regions in the UK, where 5G test beds and different use case developments and lots of investment from the government as well as from the industry. It's a collaborative initiative where lots of initiatives happen, and we were able to test lots of different use cases of 5G, and that's still continuing. That's a great initiative. I think put UK ahead of lots of other countries or on par with other countries. The other biggest thing, I think, second, the 4B as well. How does DCMS and Ofcom interact? Yes, they do interact. They have different, I think, responsibilities. If I say, Ofcom is an independent body, independent national regulator, just like most of the other regulators reports to Parliament. Ofcom's responsibility is to manage the UK spectrum, minimize the interference and get the optimum use of spectrum. In order to do that, Ofcom does lots of things behind the scene, working with other government departments. Now, don't forget, the spectrum there's loads of spectrum actually used by government that not available for civil use, we call. And Ofcom is working with the government to make some of these spectrum bands available for civil use. So some of these bands, we talk about 2.3 gigahertz band, for example, is as a result of that. And also when we talk about spectrum, we cannot, it's absolutely important to talk about harmonization. So Ofcom works very closely with other regional regulators to make spectrum, harmonize the spectrum. What it means is that other countries identify the same spectrum bands for the same purpose, technologies. So in fact, this 3.4 to 3.6 gigahertz band, it's a result of European level harmonization, which Ofcom has had leading contributions into. So the Ofcom and government, in fact, DCMS, work very closely, and working with, particularly Ofcom does lots of work to make the spectrum available, like the auction we have in the early next year. And government also have some kind of responsibility and initiating these test and trial program. The other good example is also the shared rural network that all the operators and the government made a deal to make rural area connectivity better in the coming years. So there are some things happening in the background. I hope I captured most of the points.
Yes.
Yeah.
Shall I add a little bit on there in terms of the bit about UK government contribution to 5G? From what I see, this is not me talking on behalf of the government, but the government don't tend to sort of intervene in actual direct investments on 5G where it's a commercial situation, and that is being left to the operators. However, there's two things that I've seen. One is a barrier busting work group in DCMS, which is looking at things that the environment around planning, etc., permissions, things like mast heights, that sort of thing, to make it a easier and more fluid deployment of 5G. They've also invested in a thing called 5G Create, which is a sort of program of investigating opportunities and trials for new applications to try and develop the market. And then the third thing I was going to say, and Abhaya's already said it, is where coverage is an issue. Although this isn't specifically 5G at the moment, they've also investing in the shared raw network in order to bring coverage to very non-economic areas.
I think if I also touched, go ahead, Ravi. So 3B, so 3A basically. So because Phil touched on that, the small cells is going to be is an important. For some reason, it didn't really take off until now. The reason is not the technology, nothing to do with that. It's just the business case. Deploying a small cell, the cost economics didn't work out. I think some of the factors are basically the cost of and the planning, getting the planning permission. That is a big part of that. To deploy any site, you have to have the planning permission. And as a I think result of new codes that's been introduced, EECC code, European Electronic Communication Code, government across the Europe actually, and including UK government, working to make these things easier for operators to deploy. Hopefully those things will help getting small cells to a reality, because that's a great way of giving local capacity, but it doesn't work if that local capacity have the right cost economics.
Thank you. I think we've got a couple more questions out there. 5G is a massive development. Is 6G being thought of? What lies beyond? Probably one for Andy on the sharp end of this technology.
Yeah, there's certainly some early conversations happening around 6G. It's interesting, conversation in its own right as to whether the G is even relevant anymore now, to be honest with you, as the technology continues to evolve and spread over a wider and wider set of use cases. But actually, a lot of the early conversations and experimentation around 6G are focused on things like terahertz communication. So kind of technologies like Li-Fi, very in-building focused solutions. So I think the conversation about where 5G goes and what 6G, if we do use that term, which is likely because it's good for attracting academic funding, it's good for marketing, so we'll probably see the term get used. But actually, what's it really trying to solve? We've got a long roadmap in 5G. We need to continue that deployment. We need to make sure we deliver that capability to the whole kind of geographical landmass to benefit the whole of the UK, and operators around the world have the same kind of challenge as well. So very early days, but absolutely the conversations are starting. We need to shape those conversations, and like other operators, we'll be a part of that dialogue. Yeah.
The cynic in me says that it's probably like with the old Windows strategy. If you increment the version number, you can charge more money for it.
That's also a risk.
Sorry. I think there's one question which probably is a similar, very short answer. Not sure who's best placed to pick it up. The Elon Musk Starlink project. Does that fit in anywhere in this? Does anybody have a view on it?
Yeah, so that's satellite. So I mean, step back from Elon Musk and his Starlink project. I think we think about satcoms in general. I struggle to see how it fits into a kind of mass market piece. I think that the positioning of that is maritime. I think it's aviation. I think it's extreme remote. The stuff that I'd be looking at there is just, what are the economics for it? And that's why I just don't think that works in kind of mass market mode. I think the user equipment as well is always going to be expensive for that, because I don't think it's going to get to critical mass and penetration in a mass market. I'm going to leave that there.
I mean, I can just have further comments on the satellite aspect. We have a particular use case that's of interest to us, and that's actually mobile backhaul over satellite. There is, of course, the obvious use case in rural areas where you want to deploy additional terrestrial network, but you can't deliver terrestrial transmission, be that optical fiber or microwave radio systems. But actually, one of the things we've been deploying extensively recently is satellite-based resilience to terrestrial transmission. So EE operates the UK Emergency Services Network, and to deliver those really high performance requirements and services, we need to make sure we have a very high level of availability. So actually delivering resilience at a terrestrial level is challenging. Delivering that resilience through a space-based component is advantageous. So today we're using geostationary satellites. We're very interested in understanding what things like Starlink and OneWeb could offer as low Earth orbit constellations. They could potentially offer more capacity. They'll certainly offer lower latency. They could change the economics. But actually there's some complexity in the ground terminal, of course, because the satellite's moving relative to the ground, whereas that's not the case with the geo installations. So we're very interested in that, because as operators, we see a huge market opportunity in delivering ever more reliable services to a wide range of critical industries. And to do that, we need to make sure that we can increase the availability to meet those new requirements. So satellite could have a big opportunity to play in the market from a backhaul perspective.
Thank you. I think we'll take these as the sort of last two questions. Spectrum refarming, 2G, 3G, 4G, 5G radio access networks being rationalized and spectrum refarmed. I guess there is also a question around AI machine learning for planning and managing complex virtualized 5G networks.
Yeah, I think I'm happy to start on 5G. I think everybody can probably have some comments to add on. From the operator's point of view, having worked with an operator, it's very expensive to run parallel networks like 2G, 3G, 4G, now 5G. So we have to think about what's the best cost optimum, what is more economical to do. So for example, 2G and 3G, particularly 3G, now lots of all UK operators, if I remember now, start refarming 2G spectrum and deploying 4G there, because simply to get the higher spectrum efficiency. So we've also done a study and published as part of Spectrum Policy Forum, when will 2G switch off will happen in the UK. That report is available to download if you go onto our website. So look at what are the key things that stopping that operators switching off 2G. There are some specific services difficult to get hold of for roaming type of services, but it will happen sometime because it's cost economics doesn't work, and it's not optimum to run many parallel networks.
Okay.
Yeah, absolutely.
Any closing comments on it?
And there are new techniques coming to market now that help us with refarming as well, whereas previously we had to take an entire block of spectrum and move it from one technology to another. Now we're seeing the development of dynamic spectrum sharing, particularly between 4G and 5G, that actually there's a slight cost to having this flexibility in terms of the capacity. You do lose a little bit of capacity, but it actually does mean you can have a 20 megahertz wide carrier serving LTE and 5G new radio customers. And as the percentage of handsets that support 5G increases, and we'd expect to see that now off the back of the recent iPhone announcement, then you'll see customers migrating to new radio utilization, and over time you'll then lock that carrier to new radio. So it gives you a smoother order of granularity in terms of refarming spectrum from one radio access technology to another.
Thank you. Thanks, Andy. Any closing remarks, Phil or Alastair, on that particular point? Or
well, just a general comment. I think it is sort of time to start retiring some old technology. 3G particularly, I think is starting to get close to its end of life. Perversely and strangely, 2G still has some stuff that fixes networks in for a little while longer. But when you see 4G and 5G, at least they have some ability to work nicely together over time, and we can more gradually move across those. And it sort of gets to the point of 6G as to whether actually a wholesale replacement of the radio technology in 6G is a sensible idea, and actually you maybe merge them and you don't start calling them Gs. But as Andy said, probably they will be called Gs because they get funding and they get some new supplier opportunities, I guess.
Any closing remarks on AI machine learning and its use for planning and managing complex virtualized networks?
One very quick point on that one. I mean, the number of parameters that we have to optimize in networks now, not just in mobile networks, but if you just look at engineering the internet itself, there's a huge number of parameters that need to be optimized. There's a huge diverse and ever-growing diverse range of traffic types being carried on networks that react in different ways as well. So if we're going to really optimize networks and maximize spectral efficiency and maximize performance, then machine learning based optimization engines are going to be absolutely critical. So automation across the piece and machine learning are two clear directions of strategy, and BT is investing very heavily in both.
Okay, I think we'll stop the questions there. I think I just, on behalf of the GSA, want to thank each of you individually. I mean, Andy, Phil, Abhaya, and Alastair, thank you for taking the time and contributing to the discussion. It's been phenomenal discussion, some great feedback from some of the audience, and also really grateful for all the people who've taken the time out to join this webinar on behalf of the, presented by the GSA. Thank you to all the participants, and thank you everyone for participation.
Thank you very much.
5G is the future, I guess.
Absolutely.
Thanks, everyone.
Have a good day, all. Cheers now.
Bye.
Bye. Bye.